Hello, friends. Today we are going to apply the concept of compression index for calculating the consolidation settlement. In the last video, you have seen that CC, the compression index, can be used for normally consolidated clay. So, if you have a normally consolidated clay, let's say the site condition. At a site, you have got, say, the sandy layer of thickness 2 meter, followed by a clay layer of thickness 3 meter, which is fully saturated. So this is the saturated clay layer, and this clay layer is sandwiched between sandy layer and followed by here also the sandy layer. The unit weight of this total unit weight of this sand gamma T is 20 kilonewton per cubic meter, and the unit weight here gamma for this clay for the total unit weight is here 16 kilonewton per cubic meter. And regarding clay, it is normally consolidated clay and it is fully saturated. The groundwater table is touching the ground surface. So, the situation. Now, let's say we are having a footing which is resting shear on the clay layer. So, you have a footing. This footing is here on the surface of this clay layer. This footing is a square footing. So, you have a square footing. The dimension of this footing is 2 meter by 2 meter. And the depth of the footing is 2 meter as shown in figure. So, depth of footing is 2 meter. For normally consolidated clay, the liquid limit is 35%. And the value of G, that is the specific gravity of the soil solids, GS, equal to 2.7. So, with these informations, you have a load in kilonewton that is being transferred through the column to this footing, and this load, let's say this is Q, so load Q equal to 500 kilonewton. So, the initial void ratio is say 0.9. So, you have got these informations and available with you. You need to calculate the consolidation settlement. SC. So this problem, how to address it? With the knowledge that we have gained so far, we know the compression index. So first of all, calculate compression index CC, and you know CC equal to 0.009, liquid limit minus 10. This is given by Skempton's. So you can use it, and this is going to be 35. So 35 minus 10, that is 25. So if you multiply and calculate the value, last time we have done this. So we can calculate now. Point 009 multiplied by 35 minus 10. This gives you 0.225. So the value of CC is known to you, 0.225. And there is no unit for CC. So you know now CC. Now, the load is being transferred at the top of this clay layer. So if you want to calculate the consolidation settlement, this layer, total layer, should be divided into 3 parts. So step 2, divide the clay layer into 3 parts, and for each part calculate the consolidation settlement. So if I divide this total height h of 3 meter into 3 parts, so I get h1 equal to 1 meter equal to h2 equal to h3. Therefore, h equal to h1 plus h2 plus h3 equal to 3 meter. So if you divide it in 3 layers, you have got the first layer, there is the second layer, and there is the third layer. So layer 1, layer 2, and layer 3. Now, at the mid point of each layer, you calculate the total overburden pressure. So what is the, if I calculate at the midpoint, let's say this is the footing and this is my layer 1. So at the midpoint of this layer, let's say the midpoint is A, what will be the total overburden pressure? So here you have the gamma T or gamma saturated equal to 20 kilonewton per cubic meter. Therefore, effective overburden pressure, you can calculate it at A. So for layer 1, calculate the effective overburden pressure at the midpoint. So that becomes the average pressure midpoint of layer 1, right? So if I am going to calculate at the midpoint of layer 1, Cc we have calculated as 0.225, and at the midpoint of layer 1, sigma naught prime effective overburden pressure at the midpoint of layer 1 is going to be equal to, this is going to be 20 minus 9.81 multiplied by the thickness is going to be 2 meter of sandy layer, plus here you have got 1 meter. At the midpoint it will be half meter, that is 0.5, multiplied by, what is the saturated unit weight? 16 minus 9.81. So this is the effective overburden pressure at the midpoint of layer 1. So this is going to be the effective overburden pressure. If we calculate it, this gives you 20 minus 9.81 into 2 plus 0.5 into 16 minus 9.81. This gives you 23.475 kilopascal. So at the midpoint of layer 1, this is the layer 1, I am getting the effective overburden pressure. Due to the self weight of the soil mass for the saturated clay, what is the effective overburden pressure that has been calculated. Now, you are applying a load of 500 kilonewton, and this load will be spreading like this, and say this is your layer 1, this is the layer 1. So at the midpoint, this depth is 0.5. So what is this dimension? B is the width of this footing is known to you, it is 2 meter. Now it is going to spread at 2 vertical and 1 horizontal. So the slope of this is 2 vertical, 1 horizontal. So here at the midpoint, this is going to be 0.5 meter. So this dimension is going to be 0.5 by 2. And this side also This will be 0.5 by 2. So this total dimension at the midpoint is going to be 0.5 by 2 plus 0.5 by 2, that is 0.5. So at 0.5 meter, the total dimension becomes 2 meter, the width of the footing, plus 0.5 meter. So it becomes 2.5 meter, right? And the load, as you know, the intensity of the loading here is known to you, and therefore the increase in average increase in layer 1 at the midpoint, that is called due to the external loading. So due to this external loading of 500 kilonewton, what is the increase in effective pressure that can be calculated. So this is the load, and the area here is going to be 2.5 meter at the midpoint multiplied by 2.5 meter. So this you can calculate it. So 500 divided by 2.5 into 2.5. This gives you 80 kilopascal. So you have got the average increase at the midpoint of this layer 1, the increase in effective pressure at the for the layer 1. Therefore, you can now compute the consolidation settlement for the layer 1 by the standard equation which we have discussed last time, that is equal to Cc divided by 1 plus E naught into H1 multiplied by log of sigma naught prime for layer 1 plus increase in effective pressure for layer 1 at the midpoint divided by sigma naught prime. So using this expression, it is very simple to calculate the consolidation settlement. If we substitute the values here, Cc is already computed as 0.225. The initial void ratio or the original void ratio has been computed as 0.9. So in the denominator, 1 plus E naught becomes 1.9. H1 is the height of the layer 1 is 1 meter. So you can write it 1 meter into log of sigma naught prime for layer 1 is 23.475 plus delta sigma prime for the layer 1 is computed as 80 divided by sigma naught prime to the base 10. So this becomes the consolidation settlement SC for layer 1. So if we can compute, we will be getting the value in meter. So let's calculate for this normally consolidated clay, which is subjected to the intensity of loading from a footing, a square footing. So 0.225, let's calculate 0.225 multiplied by log of 23.475 plus 80 divided by 23.475 divided by 1.9. 1.9. This gives you 0.076, 0.0762 meter. So we know the consolidation settlement of the layer 1. Now layer 1 is over. You have got the layer 2. So this is layer 2. So for layer 2, now you can compute the values. So now I've got another layer. Now SC1 is known to me. So we can write it here SC1 as 0.0762 meter. Now, we need to calculate now for the second layer. So, second layer will come here. The second layer is going to be also of 1 meter. So, at the midpoint, say midpoint is B, this is the layer 2. This is the layer 2. So, the load is going to spread like this at 2 vertical, 1 horizontal. So, for layer 2, at the midpoint, what is the effective overburden pressure? So, layer 2, please calculate the effective overburden pressure due to the self weight of the soil. When the load is not acting, the effective overburden pressure is 20, the saturated unit weight minus 9.81 multiplied by 2 meter depth plus. Now, below the footing, you are going to have this 1 meter first layer and this is 0.5 meter. So, 1.5 multiplied by 16 minus 9.81. This becomes your effective overburden pressure. So, you can calculate it quite easily. So, 20 minus 9.81 multiplied by 2 plus 1.5 multiplied by 16 minus 9.81. This gives you 29.665 kilopascal. So this is the effective overburden pressure at the midpoint. Now the load is going to spread at 2 vertical, 1 horizontal. So at the midpoint, what is the dimension that you need to calculate? So this is 2 meter width of the footing, and this side, this vertical dimension is now 1 meter plus point, so 1.5 meter. So this becomes 1.5 by 2, and this side also it becomes 1.5 by 2 for 2 vertical, 1 horizontal. That means we can now calculate the increase in effective pressure. The total load is 500 kilonewton, right? So 500 kilonewton divided by what is the now? The increase in area is 2 meter width of the footing plus 1.5 by 2 plus 1.5 by 2, it becomes 1.5 meter. Whole square will be the area. So if I calculate this, it is quite simple to calculate. 500 divided by 3.5 square equal to 40.81. So this becomes 40.81 kilopascal. Therefore, for layer 2, SC2 will be Cc, which is already calculated as 0.225 divided by 1 plus E naught into H2 into log of sigma naught prime, which is 29.665 plus delta sigma prime, that is 40.81 divided by sigma naught prime. So if you calculate it, you will be getting the answer in meter. So SC2, let us calculate. So if I calculate it, let us cancel this. Twenty-nine point six is 29.665 plus 40.81 divided by 29.665 multiplied by 0.225 divided by 1.9. This gives me 0.0445. So this is lesser than previous value. So SC2 is 0.445. 0.0445 meter, almost half you are getting. Now the last layer is the third layer. This is the third layer. So total 3 meter height of the clay. So for the third layer, we need to calculate SC3. So let us calculate for the layer 3 now. So easily for layer 3, we can calculate. This is the third layer. This is the third layer. The height is 1 meter. So at the midpoint of this, that is at C, calculate first the effective overburden pressure of the third layer. What it will be? 2 meter of sand, that is 20 minus 9.81 plus first layer 1 meter, second layer 1 meter, 2 meter, and third layer 0.5 meter. So it becomes 2.5 meter. 16 is the total saturated unit weight of clay minus 9.81. So if you calculate this, you get the effective overburden pressure. Let us calculate. So very easily we can calculate this. So let us calculate. 9.81 16 minus 9.81. This gives you 35.855 kilopascal. So easily we can calculate 20 minus 9.81 into 2 plus 2.5 into 16 minus 9.81 gives you the value. So this value is known to us. Now, what is the increase in effective pressure at the midpoint? So average shear is the midpoint. So this dimension has to be calculated. So in the denominator, in the numerator, you have got the loading in kilonewton, 500 kilonewton, and the area becomes, because now the dimension is going to be first layer 1 meter, second layer 2 meter, and the third layer midpoint is 2.5 meter. So the total area becomes 2 plus 2.5, that is 4.5 whole square. So we can calculate 500 divided by 4.5 square. This gives you 24.69 kilopascal. Now, therefore, SC3 equal to CC 0.225 divided by 1 plus E naught into H3, that is 1 meter, into log of sigma naught prime, that is 35.855 plus delta sigma prime, that is 24.69 divided by sigma naught prime. So let us calculate this. So we can calculate very easily. Log of 35.855 plus 24.69 divided by 35.855 multiplied by 0.225 divided by 1.9. This gives you very less value, 0.0269 meter. So SC3, we had divided, the clay layer should be divided into 3 parts, and for each part you have calculated the consolidation settlement SC1, SC2 and SC3, and SC3 gives you 0.0269 meter. So if you add up SC1 plus SC2 plus SC3, you get the value of total consolidation settlement, which is asked calculate the total consolidation settlement SC. Therefore, the value of SC equal to SC1 plus SC2 plus SC3. Therefore, this is equal to 0.0762. Let us add up. 762. So the total consolidation settlement is 0.1476 meter. So if you multiply it by 1000, 147.6 millimeter is the total consolidation settlement for this. If it is normally consolidated clay, you can calculate it like this. So in a easy way, you can calculate it, the total consolidation settlement. So this is a quite good example of the application of compression index, how using compression index for a normally consolidated clay, you can compute the consolidation settlement. Thank you very much.